SAS demonstration video working with output datasets. The dataset we will be using for this demonstration is called kids. I'm reading in 6 variables for this dataset: the school, the name of the student, the gender of the student, the age of the student, and the student's score on a math test and on an engineering test. And I'm going to be using proc means to create an output SAS dataset that has some summary measures based on this data. So the first thing we're going to do is read in the data and just print out the original dataset sorted by school. And we're also going to look at the means of age, math score, engineering score by school. So here is a printout of the original dataset sorted by school. And we see that each school has a certain number of students from it, and gender is entered as 1 for male, 0 for female. We have age, math score, and engineering score. And notice that there's some missing scores for the students in the dataset. If we scroll down, we see our summary of the mean, age, math score, and engineering score from each of the schools. And we see the number of observations and the number of non-missing observations from each school. So in this next set of code, I'm going to use the proc to create a new data set called SchoolDat that contains 4 observations, 1 for each school. The variables in the data set are the ends or non-missing values and the means of the variables listed in the parentheses. The names of the new variables are listed after the statistic name. I'm going to use the no print option to suppress the usual output. And I'm going to show you the n-way option when we use a class statement rather than a by statement. But in this first example, I'm just going to be using a by statement. So here I am, I'm sorting my data by school. And then I have my proc means, data equals kids, and the no print option, which is going to suppress the usual output that we see with proc means. And then I have my output statement. And so it starts with a keyword output. And then I have out equals SchoolDat. And I'm interested in creating a new variable called mean math, which is going to be the mean of math score. And then I'm creating another variable, mean eng, which is going to be the mean of the engineering score. And then I'm also creating a variable mean age, which is going to be the mean of age. And then similarly, I'm creating a variable called nmath, which is going to tell me the number of non-missing math scores that were in the data set. So how many students took the exam and had a math score, the number of non-missing engineering scores, and the number of students who were non-missing for age. And finally, I'm going to use the statistic sum to sum up the number of males. Remember that in our data set, gender was 1 if the student was male and 0 if the student was female. So if we do a sum of the variable sex, we will get the total number of males at each school. So let's run this code and do a proc print and see what's on the SchoolDat dataset. So here is a printout of the summary dataset SchoolDat. And notice there are only 4 observations because we were dealing with 4 schools and we had a by statement. We were doing the proc means by school. Now whenever SAS creates an output dataset, it has a couple of automatic variables that it puts on the dataset. One of them is the variable underscore type underscore, and the other is the variable underscore freak underscore. Now the variable underscore type underscore is a little bit complicated, and I'm going to refer you to the textbook if you want further explanation of it. We won't be using it in our processing. In the little SAS book, you can read about this variable on pages 122 to 123, and in the Applied Statistics and the SAS Programming Language textbook, I refer you to pages 148 and 149. The variable underscore freak underscore gives the number of observations in each subgroup, whether they're missing or non-missing. And then we have our new variables that we created, the mean math, which is going to be the mean math score. So for the first observation from the school Bach, the mean math score was 60. The mean engineering score was 116.4. The mean age of the students from Bach was about 12 years of age. And then we know that 6 students took a math test from Bach, 5 students took an engineering test at Bach, and we have the age for the 6 students from Bach. And we know that there are 5 males from Bach because we did a sum of the variable sex. And so again, since sex was coded as 1 and 0, if we take a sum of sex, we found out that 5 of the students from Bach are males. And if we look at the second observation from the school Dicken, there were 6 students, and all 6 of them took the math test, all 6 of them took the engineering test, and for all 6 students we know their age. And at that school, 3 of the 6 students were males. Now if we were interested in again creating a summary data set by school, but instead of using a proc sort and a by statement, we wanted to use the class statement, then we would want to use the n-way option in our proc mean statement. And what the n-way option does is it excludes from the data set any observations for the grand total. So that if we left out this n-way option, we would get another observation which was a summary of the grand total across all the observations. And I'll run this proc means both with the n-way option and without it so you can see the difference. So here we're going to first just run it with the n-way option, and we see it looks exactly like the summary data set that I was just showing you from the by statement. Now let's run this exact same code but leave out the n-way option. So I've left out the n-way option, and then here when we run it, we see here that we get this summary observation across all of the schools. So this would be the mean math score across all of the schools. So the grand mean math score. This would be the grand mean engineering score, the grand mean age across all 4 of the schools. So the n-way option leaves out this observation and just shows it by each school. In this next set of code, I'm going to take our new output data set, SchoolDat, and do some processing with it. So I'm going to create a new data set called School2. And I'm going to bring in the data set SchoolDat, and I'm first of all going to create a variable called females. And I'm going to say females equals underscore freak underscore minus males. Well, if you recall, that automatic variable that SAS generated gave the number of observations in each subgroup, both missing and non-missing. So it gave the total number of students who were read in from each school, and I'm subtracting the number of males to get the number of females. Then I'm calculating the percent male, the males, divided by underscore freak underscore times 100, and the percent females. And then I'm creating a new variable called tote kids, which is equal to this automatic variable underscore freak underscore. And then I'm dropping this variable from the data set. So let's take a look at the additional variables that we have added on our new data set called School2. So here we see, again, we're just dealing with 4 observations, and now we know that from the school Bach, 83% of the students were male. From the school Dicken, 50% were male. From the school King, there were no males, just females. And from the school Mac, 50% were male. And then we see here are our total number of students from each of the 4 schools. Let's say we were interested in getting summary statistics by 2 grouping variables. So here we're not only interested in summary statistics for each school, but within each school, we want summary statistics by gender. So how many observations would we expect here? Well, let's see. We have 4 schools, males and females, so we would expect probably 8 observations because we want from each school to have summary information for males from that school and for females from that school. So in this proc mean statement, I'm creating an output data set called school sex. And so that's going to give us our summary data for each school and by gender. So let's run this code and see what the new data set looks like. So here we have, well, not 8 observations, but 7 observations because at the school King, there were no males. There were just females. So we see here that at Bach, 0 represented females, and this would be the summary statistics on the math test, engineering, and the mean age of females from the school Bach. If we go down here at King, all we had were females. There was a total of 3 females from King, and here's the mean math score, mean engineering score, and mean age of the females at the school called King. We have the variables nmath, neng, and nage representing the number of students who had their math score, the number of students who had an engineering score, and the number of students who had an age. And again, it would be broken down by males and females from each school. So you can have a number of variables in your class statement, and if you list out even 3, 4 variables, then you will get the data set where it's summarized within each of the class levels. Let's say we were interested in merging the data from our summary data set onto each kid's record from the original data set that we read in. So we can do that by using a merge statement, which we were introduced to last week. And so here we're interested in taking the data from the data set School 2, which was the summary data from each school, and merging it back onto each student's record. So first of all, we're going to sort the data set kids by school, because again, if we are to do a merge, we need to have each of the data sets that we're merging sorted by that particular by variable. And then we're going to sort the data set School 2 by school. And then we're going to merge the 2 data sets together, kids in School 2 by school. And let's take a look at the printout of the merged data set. So here you have for each student the original variables on the data set, the mean math score from that school on that particular student's record, the mean engineering score from that particular school on that student's record, the mean age of all the students at that particular school. We also have the percent of males from that particular school on each student's record, the percent female, and the total number of kids. So what we've basically done is taken that summary data set and merged that information back into our original data set. And we can create a permanent data set with all of this information. So in order to create a permanent data set, we need to start with a libname statement, and we have a file ref where we want our permanent data set to be stored once it's created. And so we're going to start by sorting our data equals kids. So that was the original data set that we had read in, and it was a temporary data set. And we're going to do a proc means as we've been looking at before with the no print option. And notice that when we have the out equals, instead of saying out equals school dat, we're going to say out equals SAS data 2 dot school dat. So we're using the 2-level name, which tells SAS that we are creating a permanent SAS data set and not a temporary one. And then the rest of the code is exactly the same as the example code I've shown above. So to create a permanent SAS data set, we will use the 2-level name instead of a 1-level name. And we will start the code with a libname statement. So let's go ahead and run this and do a proc contents and see what our data set looks like. So if we scroll up, we see that our 2-level name SAS data 2 dot school dat indicates that we've created a permanent SAS dataset, and it's going to be stored in the E directory, which is where SAS Data 2 was referencing. There are only 4 observations on this permanent SAS dataset because it's just the 4 observations that came from the proc means. Notice that these automatic variables _freq_ and _type_ were included on the output dataset, as well as the variables males, mean age, mean eng, mean math, all the variables that were listed as statistics that we wanted on the output dataset, as well as the variable school, which was the by variable. So this is what's on our permanent SAS dataset that we've called SchoolDat. And then let's say we wanted to process that permanent SAS dataset and create a second permanent SAS dataset. So now we're creating a permanent SAS dataset School2 and saving it to the flash drive. And we're reading in the permanent SAS dataset SchoolDat, and here we're creating the same variables that we created in the earlier code. We're creating the variable females, %male, %female, and total kids. So basically it's the exact same code. I'm just showing you how we could do it if we wanted to create permanent SAS datasets rather than temporary SAS datasets. And here you see we've created another permanent SAS dataset called School2, which has the exact same variables that were on the temporary SAS dataset School2 that I had shown earlier in the demonstration. And then finally we can do a printout and see that this is a printout of our final permanent SAS dataset that we created called School2. So what I'm trying to do in this demonstration video is first of all introduce the concept of how we can use an output statement to create an output SAS dataset from a procedure, and then also bring in some of the topics that we've been covering, such as how to merge data, how to create and use permanent SAS datasets. So you see that the concepts and topics we are covering continue to build on each other and allow us to do more complicated processing of our data than what we did initially in the course. This concludes the SAS demonstration video on working with output datasets.